Welcome back. We will now look into dimensioning and designing a canful heating element like this for the electric kiln. When applying a voltage across the wire, it will heat up due to its relatively high resistance. The question is now, how many ohms should the heating element have to generate the right amount of power for the kiln we are building? The first step is to determine the design requirements by choosing what voltage the heating element will run at. In my case, I have access to 230 volts, where you might be running at 110 if you are situated in North America. And by looking at commercial available kilns of similar size to the one we are building, I have determined that 5 kilowatts is a suitable power level to aim for. As I have 3 phases available in my workshop, I have decided to split the 5 kilowatt heating element into 2 separate sections running on 1 phase each. Each element will be wound tightly and then stretched to a length fitting the heat-resistant fire bricks we made in part 1. By measuring the grooves in the kiln, I made a rough estimate of 3.3 meters. Now we can determine the current and resistance required to obtain the desired total power level. The power of each element is simply the total power divided by the number of elements, giving us 2.5 kilowatts. Ohm's law can be applied to calculate the needed current to obtain 2.5 kilowatts when running at 230 volts. Just below 11 amps, which is easily provided by the 16 amp breakers in my current workshop. Knowing the voltage and the current lets us calculate the resistance needed, again by using Ohm's law. This results to a target resistance of 21.16 ohms. When the element resistance is determined, we can enter a process of determining what combination of wire gauge and length will give us the right amount of resistance. Thicker canful wire is more expensive and requires greater length to obtain the same resistance compared to thinner wire, but it will provide a more robust element with a longer life expectancy. I've chosen to go with a 1.4mm canful wire as this results in a suitable length to fit in the kiln when wound up to a heating element. According to its datasheet, it has a resistance of 0.877 ohms per meter. The required length of heating element wire is determined by dividing the desired resistance by the resistance per meter. This gives us 24.1 meters. This is great as the supplier sells the canful wire in length of 50 meters, just enough to make the 2 elements. Now we can determine the number of coil windings by dividing the wire length with the estimated circumference of each winding. The diameter d I am using for these calculations are the inner diameter plus the wire thickness. This gives us 116 windings, which results in a 1.1 meter coil when not stretched. According to the canful wire datasheet, the coil should be stretched 2 to 3 times, getting us pretty close to the desired 3.3 meter heating element. As I mentioned earlier, you might need to adjust some of your parameters or chosen wire to reach a suitable element size. Most importantly, you should avoid a too thin wire gauge. We are now ready to look into how the heating element will be wound. For this, I've designed a 2-part 3D printed jig. One half is this part with a hole large enough for the diameter of the coil to be wound, and a small channel large enough for the wire diameter. A long steel rod with a diameter corresponding to the desired inner diameter of the coil can be inserted, and hopefully you can see how the canful wire can be wound into a coil around the steel rod with help of this jig. And finally the jig is completed by the second 3D printed part sandwiching everything together. Let's get started by cutting a piece of 8mm steel round bar to a suitable length, at least 10 cm longer than the final unstretched coil length. The end of the steel rod is filed flat, making it possible to drill a small 2mm cross hole where the canful wire can be inserted through. Here you see the 3D printed jig being screwed into a piece of wood, which can be mounted to my working table. The 50 meters of canful wire is then split into 2 equal lengths for each of the heating elements to be made. The end of the wire can be fed through the small channel in the jig and pulled through the larger hole with a pair of pliers. Then the end of the steel rod with the cross hole can be fed through parallel to the canful wire, and then the wire can be inserted into the cross hole. Using a drill at the other end of the steel rod, the winding process can begin. While running the drill, you must simply maintain a light tension on the wire entering the jig and try to keep everything straight. When the coil has been wound to a suitable length, a bit longer than we just calculated, the whole thing can be screwed apart and the coil can be slid off the rod as it springs loose when tension is removed. Each end of the heating element needs to be twisted to lower its resistance and thereby making it heat less at the end compared to the main part of the element. This can easily be achieved by folding the wire over itself and inserting it into an electric drill. Until I know how these will be connected, I'd let them be plenty oversized. The candle wire is a bit more brittle than normal copper wire, so care must be taken not tightening it too much, causing it to snap. With one end finished, we can now move on to measure and verify the final length of the heating element to achieve the desired resistance of 21.16 ohms. It is important to remember to stretch the coil while measuring so the windings do not touch each other and artificially lower the measured resistance. The coil measures around 23 ohms, so the probe is moved a bit closer until the desired resistance is achieved. The end of the coil can be stretched, allowing it to be twisted just like with the first end. Here's the final heating element, which I made another copy of off camera. With some help from my brother Sebastian, the coil is stretched to the desired length, which will fit in the groove of the fire bricks in the kiln. To be safe, I stretched them a bit too short on purpose, as it is easier to stretch them a bit more than undoing the stretching later on. Before mounting the heating elements, I drilled 4 small holes for mounting these ceramic terminal blocks, which will be used to connect the heating elements to the wires going to the control box. Now the heating element can be inserted into the fire brick grooves. As I mentioned earlier, it might take some trial and error to achieve a perfect length of the heating element to fit perfectly in the groove. We had to take it out and stretch another 5 centimeters to make it fit perfectly. The ends can now be cut to length and inserted into the ceramic terminal blocks. I have to untwist the ends as the terminal block is a bit undersized to allow the thicker twisted end to be inserted in one of the connectors. And most importantly, the heating element must not touch any of the metal parts of the oil drum. The drum will also be electrically grounded for extra safety in one of the following videos. And as the small finale of this video, I decided to plug in the heating element directly to 230 volts to verify that it heats and functions well. Using my clamp meter, the current is measured to 10.3 amps, which is 5% lower than what we aimed for. This is due to the outlet voltage dropping when drawing more than 10 amps. This is acceptable, and we can now conclude the second part of the electrical kiln series. In the next and third part, we will be making the lid and the assisted lifting mechanism. Thanks for watching and see you soon.